Welcome back to Stage 1 Mathematics, topic Growth and Decay. In this video, we're going to look at Section 2 of our booklet, more specifically indices. So, if n is a member of all positive integers, then a to the power of n is the product of n factors of a, where a to the power of n can be written as a times a times a times dot 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 times a, where what we find is that the count of a's that we have here is equal to the number of n, so n factors. Now, we refer to a as the base and n as the index or the exponent, or we could also call it the power. Now, there's some special cases we need to take note of, and the first one is to take care with negative bases. So a negative base raised to an odd number, negative base raised to an odd number is negative, or it will yield a negative result. So think about, let's say, negative 2 to the power of 3. It will be negative 3 times negative 3 times negative 3, so it will come out as a negative. And a negative base raised to an even number is positive. So negative 2 to the power of 2 is going to come out as 4. Also, for example, take care to recognize the difference between minus 2 to the 4 and inside the parentheses minus 2 to the power of 4. So the position of these parentheses is going to have a significant impact on the final outcome of this expression. So in the first one here, we're going to get negative, then it will be 2 times 2 times 2 times 2, and that will come out to be approximately negative 16. I shouldn't say approximately, it will come out as negative 16. Whereas in contrast, on the example on the right, it's going to be negative 2 multiplied by negative 2, negative 2 and negative 2 here. And the outcome of this result is going to be positive 16. So the use of parentheses has a substantial impact on the final outcome of negative bases. Going down, we're going to have a look at some examples of the index laws. So these are generally something you should just memorize because they're really useful to know off the top of your head. So when we're dealing with anything raised to the power of 0 with exception to 0 itself, we're going to get an outcome of 1. And notice I said that it can be anything except for 0, so a cannot equal 0. And going down, we've got a to the power of n times a to the power of n. When we have a situation like this, then the base will be the same, and it will become m plus n. So we add the two powers together. Now, conversely, with the division, we've got a to the power of n divided by a to the power of n. So similar to multiplication, it's like the opposite. It becomes a m minus n. So rather than adding together like they do in the multiplication, in division they subtract. So the one in the denominator will be subtracted from the power in the numerator. Now, this is where some people get a little bit confused. We've got a to the power of negative n or minus n. This is a little bit funky in that we have the base, but the base goes down in the denominator with the n there, and it becomes 1 over. So a to the power of negative n is equal to 1 over a to the power of n. Similarly, if we go down to a to the power of n, m times n, what we'll find is that these two, the two powers multiply. So it will be m times n, or you could rewrite that as mn, like so. And similarly with ab to the power of n, then we're going to go in, n will multiply everything, or will be everything inside the parentheses will be raised to the power of n. So it will be a to the n times b to the n, like so. And this is similar with the fractions raised to the power of n. It will be a to the power of n, and then b to the power of n, like so. So now that we've got those out of the way, let's go down and do some examples. So looking at example 1, simplify, we've got x to the power of 4 times x to the power of 3. So to simplify this out, we're simply going to go x 4 plus 3, and that will equal x to the power of 7. Now in b, we've got 2a to the power of 5, and all of that to the power of 3. So the 3 is going to come in the brackets, and it will go 2 to the power of 3 times a 5 times 3, like so. And then simplifying that out, we could leave it as 2 to the power of 3, like so, and then a to the 15. Or we could simplify it, and we could deal with this coefficient at the front, and 2 times 2 times 2 is going to be 8 to the power of 15. Going down to c, we've got 4 to the power of 4 divided by 4 to the power of 7. So the common base is going to be 4, and it will be 4 to the power of 4 take 7, like so, and that will evaluate down to be 4 to the power of negative 3. And notice that we've got a negative power now. So what we can write is it will become 1 over 4 to the power of 3. And if we want to evaluate that out even further, what we can go is 4 times 4 times 4. So 1 over 4 times 4 times 4. And that will become 1/64th, like so. Moving on to d, we've got negative 2a to the power of 3, all to the power of 5. So we're going to get negative 2, and I'll put it in parentheses, like so. And then it will be a to the power of 3 times 5, like so. And then simplifying further, it will be negative 2 to the power of 5. So that's going to be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So that's going to become negative 32. And then the a will be 3 times 5, and that will be 15, like so. So that's how we could do some simpler examples there. Now going down, we've got a few more examples, but it gets a little bit trickier. All right, example E, it now starts to get a little bit trickier in that we've got many factors in the numerator and denominator that we must deal with. But the first thing we're going to do with this sort of question is we have to first deal with the parentheses. So everything inside here raised to the power of 2, and everything on the bottom of or bottom right of this expression, so 3mn to the power of 4. So we'll get rid of the parentheses first. So we're going to find that we get 3 times 3 times 2 times m to the 4 times 2 times n to the 2 times 2. And that was the numerator. Now we have to deal with the denominator. So we're going to get p squared times 2 up there, like so. Then our second factor, downstairs we're going to get 3 to the 4 times m to the 4 times n to the 4. And then that will be p to the 5 upstairs. Now, the next way I'm going to look at this is I'm going to eliminate or see what I can get rid of. So we've got the p's here they're going to counteract one another. The 3's, base 3's there, the m there, and then the n's here. So using the rule around division, the index laws around division, we're going to get 3 to the power of 3 times 2. So 3 to the 6, take 3 to the 4, times m to the 8 minus m to the 4, times n to the 4, take n to the 4 like so. And then downstairs, we've got the p, but notice that we've got the p over here. So downstairs, we'll just leave it at 1. And in fact, we'll get rid of it. So we're not going to write this as a fraction anymore. We'll just write it as an expression. So we'll get p to the 5 minus 4 like so. Now simplifying this out, 3 to the 6 take 4, that's going to be 3 squared times m to the 8 minus 4, that will be m to the 4 times n to the 0 times p to the 1. And rewriting that out, it will be 3 squared, or we could say 9, but I'll leave this one as 3 squared today. And then m to the 4. N to the 0 becomes 1, and p to the 1 becomes just simply p. So this would be our final solution here to this problem. Going down, we're going to look at writing things as powers. So one way to think about this is write as a power of 5. So what we're expecting in this case with a is we're going to get 5 to the power of something, but we're not sure. Now, eventually this will allude to something that we're doing later down the line in this topic, but one way to think about it is what or how many values of 5 do we have to multiply together to get a value of 125? And what you'll find is that if we go 5 times 5, we're going to get 25. And then if we multiply it again, we're going to get 5 times 5 times 5 equals 125. So what we can see is that 125 can be written as a power of 5, as in 5 to the 3, like so. Going on, we've got 25 times 5 to the n. If we were going to simplify this expression here, what we could write this as is, we'll think about how can we rewrite 25 as a power of 5. And what we can say is 25 is the same as writing 5 to the power of 2. Then it's 5 to the n here. So simplifying this expression will be 5, 2 plus n, like so. Now in question 3, it says write the following without brackets or negative indices. So we don't want to have our negative indices. So looking at part A, we've got 4ab, b is raised to the negative 3, then outside it's a 2. So what we can do is firstly we'll deal with our brackets. So we'll go 4 squared times a squared times negative 3 times 2. Simplifying will be 4 squared, a squared, and then b to the negative 6. And the question says write the following without brackets or negative indices. So we've got to deal with this b to the negative 6. So the way in which we can do it is we'll go 4 squared, a squared, all over b to the 6. So the negative in front of that b just simply means that b moves down to the denominator. Now looking at part B, notice that there's quite a lot going on in this particular question, but not to worry. We will first solve it by dealing with how we've done all the other questions. So firstly, we're going to get rid of the parentheses. Then we're going to collect our like terms, and then we will simplify. So dealing with the parentheses, we're going to, on the first line, we're going to get 2 to the power of 2 times x to the power of 3 times 2. So that will be 6. Then y to the power of negative 3 times 2. So that will be y to the power of negative 6, like so. And that's times 3 times x to the negative 4 and y squared. Now down in the denominator, we're going to get 2 to the power of negative 3 x. Negative 2 times negative 3 is positive 6, and then y to the negative 3, like so. Now rewriting all of this as not a fraction, we're going to get, so the 2 to the power of 2, that will become 4 x to the 6, y to the negative 6 times 3x to the negative 4 y squared. Then we're going to get these factors down in the denominator and move them upstairs. So 2 to the negative 3 is going to become 2 to the 3. Then x to the 6 is going to be x to the negative 6, and y to the negative 3 is going to be y to the 3. Moving onwards, we have to deal with these coefficients. So 4 times 3 is 12, and then 2 to the 3, that will be 8. Now we've got x, so x to the 6 minus the 4, and the negative 6 there. Then we have to deal with our y's. So the negative 6 here, 2 and the 3. So it will be negative 6 plus 2 plus 3. Alright, sorting this out, we're going to get 12 times 8, that will be 96 times x to the power of 6 minus 4 minus 6. Well, that's simply going to be to the negative 4, and then the y, negative 6 plus the 2 plus the 3. So negative 6 plus 5 is negative 1. So simplifying this all out, we're going to get 96 over x to the power of 4 times y.